the period of y is equal to sine of b times x and y is equal to cosine of b times x. We spoke about this in the last video. This is how we define the period. So let b be any positive real number. The period of p of these functions is equal to 2 pi divided by b. So that is how you compute for the period. And our understanding of the period is, it is the length of the interval that contains one sine curve. Or you can look at it as the horizontal distance covered by one sine curve. When your function is this, y is equal to sine of x, so b here is equal to 1, period is equal to 2 pi over 1. Here, your b is 2, so 2 pi divided by 2 is equal to pi. That is the period of this function. When your function is something like this, y is equal to sine of 0.5 times x. So this one is your b, and 0.5 is 1/2. And 2 pi divided by 1/2 is equal to, that is 4 pi. When your function is sine of 6 times x, or y is equal to sine of 6 times x, b is equal to 6. Again, 2 pi over 6 is equal to pi over 3. And when your function is defined in this way, sine of pi times x, now that one's kind of confusing. It is kind of tricky because some students are not able to recognize that here b is equal to pi. So your period here is equal to 2 pi over pi. That is your b. So it's equal to 2. Our symbol for period is p. Visually, what does the period do to the graph of your simple sine function? You know what? I think this is the first time I'm calling this a simple sine function. Y is equal to sine of x. So what does the period do to the graph of your sine function? So let us now compare this graph with, so here the value of b is 2, period is pi. So the length of the interval that contains one sine curve is equal to pi. So you have one sine curve in that interval. Now let us compare that with a function defined by y is equal to 0.5 times x. Okay? Y is equal to sine of 0.5 times x. B is 1/2. And computing for your period, okay? So what we have here now is a sine curve that travels a longer interval. So the interval that contains one sine curve is longer now. It's 4 pi. Now we have technical names or technical words to describe what happens here. We call it compression or horizontal compression and horizontal stretching. So when your b is greater than 1, it produces a horizontal compression. It compresses. Look at what happens. Look at what happens. Compare this with this. So it's like you are compressing the graph of your function y is equal to sine of x. And look at what it does with your graph when your b is less than 1. Positive but less than 1. So what it does is it horizontally stretches the graph of your simple sine function. So remember that, horizontal compression and horizontal stretching. Compression when b is greater than 1, stretching when b is less than 1.